Okay, now, hi everyone. We continue to the second code, which also um, will create the same hardware, which is the multiplexer, 4-to-1 multiplexer, but this time we use behavioral modeling, okay, using if and else method, okay. So we can either comment this module so that we can retrieve later, or we can modify the code. So in this case, let's say we comment it. Okay, we comment the code. So to make a multiple line comment, you just use the forward slash and then star. And at the end of the module, you use the star and then forward slash. So that's all. So now your module not going to be compiled by the simulator. So now we start module number 2. Okay, so we can start module number 2 here. So module uh, number 2. Okay, so module. Okay, so to make it better, maybe I move this to the bottom so that you can see the module number 2. So this is module number 1. Number 1, right? Module number 2, same name as module number 1. So that we don't have to create separate file. Then you open and close bracket. Okay, and then you can also copy from here. Okay, so this time we make it faster so that we can get the whole idea of the project. Okay, so we have input. So same 1-bit input for D0 until D3 and 2-bit input for selector. Okay, and the same output. All right, so no changes on this. Okay, right. So now we move on to the body of the program. So we don't forget to put end module, okay, and enter it. If you don't enter it, it will not turn to the blue color. That means that your module is not active. Okay. And then we start the behavioral modeling using IfElse. Okay, using IfElse of the what we call of the multiplexer. So for IfElse, okay, we need to use always block. We don't use assign statement. Okay, so only for normally for data flow way of coding like this one, we use assign statement. But for if else, we use always block. Okay, so to start, write the code. So you start with always add. Okay, and then you put all the input inside this sensitivity list. This is what we call as sensitivity list. So inside the bracket. So the bracket here means that the sensitivity list. It means that any input signal should be declared inside this one, should be inserted inside this bracket, so that any changes to the input will affect uh, the process inside the begin and end of the block. So this is what we call as one block of always. Okay, so we start giving the input here, so which is D0, okay, D1, D1, D2, and D3, and selector as well, selector cell as well. So normally we put or here, or okay, or D2, then or D3, or selector. Means that any changes either to D0, D1, D3, D2, D3, and selector, it will execute the process inside the always block. So between the begin and end block here. Okay, so what it means by changes? Changes means that is that any event. Event means either the signal change from 1 to 0 or 0 to 1. So that's what we call as changes or event. So we start here by starting the with if. So we set the condition. So if, so let's see the multiplexer so that we can get the idea. So here, if the selector equal to 0, 0, okay, if the selector equal to 0, 0 means that the output equal to the 0. So if the selector equal to 1, 1, for example, so here 3 is 1, 1, okay, we already convert it. So the output will become equal to D3. So that's what we translate in our code. So if selector, so for the case of Verilog syntax, equal is you need to have double equal. So that's actually the what we call as the expression equal to 2 prime B00. So it means that if selector equal to 2 prime B00 as we discussed just now, the output, okay, output equal to the B0. Okay, then we terminate the statement. Okay, statement in line 18 we terminate with the what we call as a semicolon, and then we go to the next. Okay, else, and then we put if. We check the next one. Okay, if selector equal to 2 prime B01. Okay, and then the output equal to B1. So and so on lah. You continue until end of the selector, which is it 1, 1. So else if selector equal to 2 prime B10, and then output out equal to D2. Then you put the statement terminator and then else, okay, out equal to D3. So this is actually the way you write the IfElse statement, IfElse code, right? So at the end of the else, okay, which is line 23, no need to put if because we already cover all the possibilities of the input. Okay, beginning from selector 00, 01, 10. So else here means that the selector equal to 2 prime B11. So no need to write this because the compiler will know. Okay. Okay. All right. So we finish the coding for the multiplexer using if statement. So this way of code is easier to write compared to the first one, like this one. We need to know the detail of the equation. Okay, now we don't have to just use a behavioral way of coding. So now it's time to do the compilation. Okay, so we expect we have one error here. Okay, one or two errors or more maybe. Okay, so maybe you can guess what is the error after this. So let's compile to see it. Okay, yes, because you made changes. Okay, now we see 6 errors. Okay, and it might make it bigger. And then don't worry if you get errors. That's actually the learning process. So now you can see it's mentioned to you procedural assignment error at multiplexer 4by1.v. So this is actually your design file. Okay, you double click on this. It's mentioned object out on left hand side of assignment must be a variable or register data type. So it means that your register data type means that you need to declare out as a register data type. So any left hand side, okay, element in the always block here, so it has to be a register data type. So how do we know left or right? So use the equal sign here. So the equal sign here, the acts as a what we call as the divider, so that we can see on the left is actually out, on the right is actually the D0, D1, and so on. So out has to be registered data type, so need to be declared here. So Rex, and then you compile again, and then you get yes, and then you can see from now no errors. So remember, so multiple errors may be due to the one error. So don't worry about a lot of errors that you encounter when you compile your design. So now we have no errors, only we try warning. So always check the warning, whether the warning related to your design or not. So none of this warning specifically mention about your design Mux4by1.v. So means that is okay. So now we are in the stage of we already compile and see success, and then we analyze the design, and then we also synthesize it as well. But now we can see the equivalent RTL. So now we see the design at the RTL level compared to the first one, which is lower level at the gate level. Okay, now we have the same multiplexer. Okay, all right. How do you know? Do you check the input and then you check the output? So all the interconnection are there. Okay, no missing interconnection, right? It means that your design is okay in terms of hardware realization, or in terms of synthesize. Is synthesized correctly to the equivalent hardware. All right. So in the next video, we're going to explore the next code, which is using case statement. Okay, stay tuned, and then thank you.